Hey guys, welcome to your Chapter 5 Lesson 7 notes on scatter plots and trend lines. By the end of the day, you'll be able to write an equation of a trend line and line of best fit, and also to use a trend line or line of best fit to make predictions. Before we talk about trend lines, we need to talk about scatter plots. So a scatter plot is a graph on which the dots are all scattered. It's just like boom, boom, boom. We're going to draw some. So you're going to take your ordered pair. Remember, ordered pairs have your x value followed by your y value, or rather your independent value followed by your dependent value. So we plot 3 by going right 2, up 3 right here. We plot -1, -2 by going left 1, down 2, where we go over 0, up 2, and then over 2, up 0. That's a scatter plot, where the points are just kind of scattered on there. Our key idea of the day is that you can determine whether two sets of data are related by graphing them as ordered pairs. Again, ordered pairs are your XY guys. If the two sets of data are related, you'll notice a pattern. So you'll be able to use a line to estimate or sometimes even to predict a value. There are 3 kinds of relationships data can have. Here, this guy is, we see as x increases, that is, as x gets bigger. Will this work? Yeah, nice. As x gets bigger, notice that y is also getting bigger as well. So as x gets bigger, y gets bigger. Oh, my arrow didn't work. Go. Aha. Y increases. So as x increases, y also increases. Oh, y increases. We call this a positive correlation. Positive correlation. This is because if you, maybe I should try spelling correlation correctly. This is because if you drew a line kind of that described this relationship, this line would have a positive slope. That's a fun way to help you remember it. But what if, on the other hand, your line would have a negative slope? What should we call this guy? Well, why don't we just call it a negative correlation, shall we? Negative correlation. A negative correlation is what happens when, as your x increases, y is not increasing. Now look at that. Those values are going down. Y decreases. Okay. So negative correlation means there is a relationship, but it's negative. As one gets bigger, the other gets smaller. Positive correlation means there's a relationship there, and as one gets bigger, the other one gets bigger. But notice relation, okay? These are related. They're co-related. They're related to each other. If you don't have a relationship, if they are not related, we just say there is no correlation. Because look at these guys. This guy's all over the place. He's like a hot mess. They're just not related. X and Y are not related. It's not that as X increases, Y also increases, or as X increases, Y is decreased. They're just, nope, there's no relationship there. Cool. So we've been talking about correlation. That's just they are related. They have something in common. This is different from causation. Causation is when something causes it. Okay, so causation is when a change in one quantity will cause a change in another quantity. This is not always the case. Just because two things are correlated, they're related, does not mean that they cause each other. So let's look at some examples, and I'll kind of use that to prove the point. Okay. So for each of these guys, we're going to determine is the correlation positive or is the correlation negative? If there is a correlation at all, maybe there's no correlation at all. Here, let's do some shortcuts. Positive, like this. Negative, like that. Or no relation, like that. Yeah. Okay. So let's look at the first one. You have the number of loaves of bread baked and the amount of flour used. Well, that's definitely a positive correlation. That's a positive correlation because the more bread you bake, the more flour you will use. So yes, positive correlation. And this is causal. This is a causal relationship because the amount of bread you use causes how much flour you use. Those are directly related. That is a causal relationship. However, when we look at B is the number of mailboxes in a city and the number of firefighters in a city. This has a positive correlation because as the more mailboxes you have, the more firefighters you will have. But it's not that you need firefighters to go with your mailboxes. There's something else there. So this is not causal, but they are related because of an underlying issue. The more people you have in a city, the more mailboxes you have. And the bigger a city is, the more people you'll have and the more firefighters you'll need. So they're related, but the mailboxes do not cause the firefighters, or the firefighters do not cause the mailboxes. So this is not causal. Let's look at C. Your shoe size and the number of siblings you have. Well, my siblings and all have the same number of same number of siblings, and we all have different shoe sizes. So there's definitely no correlation there. There is no relationship between your shoe size and the number of siblings you have. Come on. Okay? So let's look at our last one. The cost of a family's vacation and the size of their house. This one's actually tricky because might be a positive correlation. Maybe. I was going to say it's positive because the more money they have to spend on a vacation, the bigger their house probably is. However, maybe they spent all their money on a house so they can't afford a big vacation. Or maybe they saved money by buying a tiny house and now have a lot left over for a vacation. You don't know. So there might be a positive correlation. Either way, it's not causal. There you go. Correlation does not imply causation. Just because things are related doesn't mean they cause each other. Okay, cool. But how can you tell what their correlation is? Well, you can think hard about it. You can look at the graph. That's more effective. So let's do that. Okay, here we've got a table, and we're going to decide, first we're going to make a scatter plot of this data, because when I look at all these numbers, I can't really tell a relationship there, but it's going to be a lot easier if I can just find a picture of it. So our question is, what type of relationship does the scatter plot show? It says each because there used to be two, but just one. Okay, what is the type of relationship here? What kind of correlation do we have? So let's go ahead and graph. We want our altitude to be our dependent variable. We want our temperature to be our independent variable. But even so, we can't really call them dependent and independent because we don't know if they are causal. But that's just what we're going to go. Let's go ahead and label our axes really quick. Altitude in meters and temperature in degrees Fahrenheit. Remember, you must label your axes. Okay, so at 0, our temperature is 59. Let's go by 10, this goes by 20, so this is 50, so this is 59. Okay, and then we did that one at 500, which is going to be here. 59.2. Man, it got a little warmer. That's exciting. We're getting warmer. We're getting even warmer. Okay, cool. Oh, no. Now we're getting colder. because it's 40. Oof, check that out. Okay, 2,500 gives us 29.8. Wow. 3,000 gives us 29.9. 3,000 I just did. 3,500. Wow. 3,500 only gives us 18.1, which is going to be like here-ish. 4,000 gives us 26. What? Heat wave. And 4,500 gives us 12.4. Well, if this is 10, then 12 is about here. And finally at 5,000, our altitude. Altitude of 5,000, our temperature is 0.6 degrees Fahrenheit. That's super cool. Okay, check it out. Notice there's not a direct relationship there, but there is a trend. They follow a trend, and this trend is going down. So this is a negative correlation. The reason this is a negative correlation is because as the altitude increases, the higher you go, the lower the temperature is, the colder it gets. So as one increases, the other decreases. Negative correlation. Okay? So regardless of the type of correlation you have, it can be positive or it can be negative. You can use what's called a trend line. It's a line that follows a trend. Great, huh? You can use a trend line to show the correlation more clearly. I've kind of been doing this just to show the direction here. There's the trend line. Here's a trend line. Kind of sloppy, but whatever. Here's a trend line as well. There's no correlation, so there's no trend line, because what is it going to go? Like this? I think not. Alrighty. Okay, so once we have our trend line, we can do two things with it. We can either interpolate. That is, inter means go between. Or we can extrapolate. There. Oh, sorry. Interpolation to fit our sentence. So we have interpolation. We also have the opposite of inter is extra. And the opposite of between is outside. Just like an extraterrestrial is out of this world. It's an alien, or extranjero is someone who is not from this country in Spanish. So anyway, interpolation is going between values. Extrapolation is predicting outside of those values. For example, we could interpolate what the temperature would be here. It would be somewhere in this area. That's interpolation. But we could also extrapolate. We could keep the trend line going and figure out what would the temperature be at 5,500. Well, it would be below zero. So let's not do that. That is just too cold for me. No, thank you. Anyway. Okay, so here let's do exactly that. We're going to make a scatter plot, and then we're going to use our trend line to interpolate and then extrapolate. So the very first thing we need to do is we need to put our points down. Here we've got our age, and this is going to be a causal relationship. So we have our independent variable. Time is almost always independent. And we've got our weight. But wait. Okay, so Mundo Panda is 1 month old. He weighs 2.5 pounds. Okay, well, each of these lines is 3. So that's close. 2 gives 7.5. Well, 7.6. 3 gives 12.5. You know what? I'm just gonna plug these in real quick. Okay, there we have it. There's our scatter plot, and wow, there's a pretty tight relationship here. So there's a high correlation because they all pretty much follow the same line. Okay. And now we're going to estimate the coordinates of 2 points. Oh no, we didn't actually draw a trend line, did we? Okay, we need to draw our trend line by connecting the line, by drawing a line to connect as many points as we can, or by getting as close to as many points as we can. How about that? Does that look like a good line to you guys? I think so. I think that looks like a good line to me. And now we need to pick what 2 points are close to our line. I like this 8 guy. That's pretty close. And what else do I like? How about 4? Man, look at that. Oh, yeah, look at that 4. That 4 is like right on. That's super neato. Okay, so now we're going to use those points to do, to write the equation of a line. So we're going to use point slope form. Oh, but guess what? We don't have to estimate the values. We can use what's in our table up here. That's so nice. Okay, so we have 2 points on our graph. We've got 4, 17.1, and we've got 8, 37.9. And now that we know 2 points on our graph, we're going to use point slope form. I'm sorry, my Bible study text group is going off. I forgot to put my phone on silent. Okay, here we go. So we're going to use point slope form to write the equation of this line. The first thing we need to do is find the slope. How do we find the slope? Well, slope is your rise over run. It's your y's, 37.9 and 17.1, find their difference, and it's the x's, find their difference. That works out to 20.8 over 4, which is 5.2. So we're going to say our slope is 5.2, and then we just need to pick our whatever point we want to deal with, and I vote that we use this guy because the numbers are smaller. So there you go. Okay. So we got y minus 17.1 equals 5.2 times x minus 4. And that's awesome, but we want to put it in slope-intercept form, and I'm going to show you why. Not why, get it? Because we're going to solve for y. So in order to get it in slope-intercept form, we want y equals mx plus b. So I'm going to go ahead and distribute this I don't know why I said 4. This 5.2 to both sides of this distributive guy right here, giving us 5.2x minus 20.8. This guy stays the same. And now we need to add 17.1 to both sides in order to get y all by himself. So now we have our equation, which is y equals 5.2x minus 3.7, which tells us really that our panda grows 5.2 pounds. Are we dealing in pounds? Yep. Grows 5.2 pounds every month, but in month 0 he weighed negative 3.7 pounds. So that doesn't make sense, but it's an estimate. Okay, so now we want to estimate how big is a 7-month-old panda going to be, and we're going to plug in 7 month for our x values. And then after that, we'll find out how big is a 13-month panda. So if we look at our graph, we have to make an estimate. At month 7, how big do we expect our panda to be? We expect our panda to be approximately 32 pounds. I'm going to estimate 32 pounds. But then we can actually plug it in and see. Okay, so we take our equation and we do some interpolating by finding, so actually that's what we just did. We interpolated because we found a point between these guys. It's inside. Is it actually 32? Well, what happens when we plug in 7 right here? we get 5.2 times 7, and then we subtract 3.7 from that, and we get 32.7. So that's cool. I was close. So that's interpolating, but what about extrapolating? If we continued this trend on and we kept going out 13 months later, okay, so this is one, that's that distance. So at 13 months, how big is our little guy gonna be? What does that look like? If this is, well, that's 6, so this is 12 more. Ooh boy, I'm gonna guess 62 pounds. That's my guess. Is he gonna be 62 pounds? Well, let's find out. Okay, so we do the same thing, except this time, instead of plugging in 7 for x, we're gonna plug in 13. Why not? I missed my decimal point. Okay. So do 5.2 times 13 minus 3.7, and that comes out to 63.9. So I was kind of close. There you go. So you can use a trend line to interpolate data to find a guess between two items, or you can extrapolate from your data. So you can continue the pattern and make a guess from there. Yep. This, by the way, has a positive correlation because the more he grows, or the older he is, the more he will grow. Hopefully he will eventually kind of taper off so that we don't get a giant panda. But okay. And that's it. I hope you have a wonderful time on your home.